So let's talk about function arithmetic. If someone were to ask, f of x plus g of x or f of g of x, right? That's another way of saying composition of functions. So I'm going to do a few things in this video. I'm going to do the arithmetic part, and then I'm going to do composition, and then I'm going to do inverse. So let's start with arithmetic. So if f of x is 2x plus 7 and g of x is 3x squared. If someone says, what is f of x plus g of x, you actually add these together. So you have 2x plus 7 plus 3x squared. And our answer is just 3x squared plus 2x plus 7. So you have f of x plus g of x, that's the first part. If they asked us to do f of x minus g of x, we would follow the same protocol. We would say 2x plus 7 minus 3x. If they say, what is f of x? If it's f of x divided by g of x, then we will just say 2x plus 7 divided by 3x squared, and you can leave that as your answer. Okay, so that's the division part. And then if it's multiplied, then you're technically just going to distribute. So you have 2x plus 7 into 3x squared like that, and you could technically just distribute that 3x squared to both terms. So let's use the same problem divided by g of x. So you have 2x plus 7 for f of x, and you have 3x squared for g of x. So if they ask us to find, so we've done the arithmetic of adding and subtracting. Now our Tyler Wallace textbook in chapter 10 focuses on this issue of function arithmetic. But let me give you an example now of composition of functions. That is a situation where they tell you f of g of x like that, or f of g of x like this. Those are two ways that they write the problem. That means that you take the g of x, okay, whatever that value is, and you substitute it in for x in the f of x equation. So that becomes 2 into 3x squared and then plus 7. So do you see what we did? We took the 3x squared and we substituted it in for the x that was originally there. This becomes 6x squared plus 7, and that's the end of the problem. That's the composition of functions, where you take the value of g of x and you substitute it in for the value of f, for the value of x in f of x. That's what you're doing when you're finding the composition of functions. Now, if I ask you to find g of f, right, so the composition the other way around, that means you take 2x plus 7 and you plug it in for x squared. So that becomes, instead of 3x squared, it becomes 3 into 2x plus 7 squared. So then that becomes 3 into 2x plus 7 and 2x plus 7. So you distribute this, you get 4x squared plus 14x plus 14x plus 49. And you have a 3 outside. So you add those up together, you get 4x squared plus 28x plus 49. And then you have a 3 outside. So you could distribute that 3 into everything. Depends on what the answer is in the question. Some questions, they might leave the answer in that form, 3 into 4x squared plus 28x plus 49. Or they can distribute it in, and then you can write whatever that is. So 3 times 4x squared and so on. So that gives you 12x squared, and then you have 3 times 28 plus 84x, and then plus you have 49 times 3 as well, and that is 147. So that would be the answer. Sorry I wrote a lot at the end there, but the idea is you just write the 2x plus 7 and you square that first, then you distribute the 3 in. So notice the order of operations is very important as well. You want to take care of the parentheses first, and then you can go on and do the work by distributing the 3 afterwards. Let me know if you have any questions. Again, chapter 10 of Tyler Wallace, we have function arithmetic, and you can do composition of functions, function arithmetic, and it'll give you more practice. This is very applicable in calculus, so keep that in mind as you prepare for the road ahead. Have a great day.